Let's solve the equation 3 sine x plus 2 equals 5 cos squared x minus 1 for x is between 0 to 2 pi. So whenever we solve for trigonometric equations, we have to make sure that it's written in just one type of trig, like all is cosine, all is sine, or just tangent. So if we look at the given, we have a 3 sine x plus 2 equals 5 cos squared x minus 1. We don't have an identity for the sine x, but we have for cos squared x. Cos squared x can be written in terms of sine. So this is from the MF19 identity. Okay, this is written in the MF19, don't worry. This is sine squared x plus cos squared x equal to 1. And you can rearrange this. I can write, I can make cos squared x the subject equal to 1 minus sine squared x. And that's what I'm going to use. You can also use sine squared x equals 1 minus cos squared x. Okay, but I'm going to use this. So let's have the given. We have 3 sine x plus 2 is equal to 5. And I'll use that identity. Make sure it's in brackets so you know you'll expand it later. So we have 1 minus sine squared x minus 1. Okay, let me just expand that bracket. We have 5, okay, minus 5 sine squared x minus 1. And that becomes just 4, okay? And I'm going to move everything on the right-hand side going to the left-hand side. So that's 5 sine squared x, okay? And then we have a negative 4 or a minus 4 plus 2. That becomes a minus 2. Then 3 sine x minus 2, okay, equal to 0. So if you imagine this is another like a quadratic, like a hidden quadratic behind this trig. You can imagine that like the sine squared x kind of looks like a 5x squared plus 3x minus 2 equal to 0. So you can actually factorize this as how you will factorize a quadratic. So let's have this, let's factorize this. You'll get a 5 sine x minus 2 and sine x plus 1 equal to 0. And now let's solve. We have 5 sine x minus 2 equal to 0. Okay, 5 sine x equal to positive 2. Divide both sides by 5. You will get sine x equals 2/5. Okay, and then we have x is, let's inverse that. Let's have arc sine of 2/5. Okay, and that will be equal to 0.4115. Make sure your calculator's in radians because we're working with a radian given. Okay, so that's the first equation. There might be some more equations because we need until 2 pi. Until 2 pi means like the whole picture of sine. And sine is positive, okay, like the 2/5. It's positive in the first and the second quadrant if we use the ASTC rule, okay? So before I find the other one, I'll just find the other factor, okay? And then I'll show it, I'll show the like finding the other solutions using a graph. So let's have sine x is equal to negative 1, okay? X equals arc sine, okay, or the inverse of sine, negative 1. That's x equals negative pi per 2. Okay, and negative pi per 2 is not within our domain, okay? Our domain is from 0 to 2 pi. So let me just draw the sine graph, okay, just to help you imagine this better, okay? Let's say this is the sine graph, okay? So we have a sine. Our amplitudes like from positive 1 to negative 1, okay? 2/5 is like 0.4, so it's somewhere here. So if you draw a line here, you'll see that it will strike the graph 2 times. Okay, so that means we don't have just one solution, we need another one. The 0.4115, the angle that you get from the calculator, will be the one from the first quadrant, which is 115. And looking at this, remember this is the normal sine graph. Okay, it's gonna be 1 at pi over 2, okay, 0 at pi, and then -1 at 3 pi per 2, and then this is back again at 0 in 2 pi. So you're looking for another solution, which is here in this area. So to get the second solution from our first factor, I will take our answer, okay, so that's x equals pi, okay, this is pi, and then I'll just minus our calculated result, and you will get the second solution, which is 2.73 correct to 3 SF. So our answers, okay, let me just write down the solutions here. So we have 0.412, we have 2.73, and then the negative pi per 2, that's way within our domain, so we're not going to choose that. So let's find this -1. -1 is here, and then you will see that it strike the graph once, okay, which is exactly at 3 pi per 2. So your solution will be -pi over 2, which is not valid because that's not within our domain, but 3 pi per 2 is within our range. So that's 3 pi over 2. And those are all your solutions.